And we're back. We're going to talk fiber optic outlets at this point. At first, this is going to look like we're talking like looking like we're talking about fiber optic connectors. But what we're going to find out in a minute is that's really what an outlet is. It's just two connectors with an adapter in between. So, just as we get started, we're not going off at the tangent here. First thing we need to realize is when dealing with fiber optic, it is more expensive and time consuming. We're probably going to find as time goes on, we will probably have more fiber optic outlets throughout our building. But as of now, copper is getting the job done, so most things are copper. But let's at least touch on fiber and recognize what would be involved in dealing with fiber optic outlets. First off, it is more expensive and time consuming. The process really is I would need to strip off my jacket, the jacket out here, the outer insulation, cut away the strength members until I get down to my two fibers down here that I'd be dealing with. After that, I'm going to use my stripper here and cut off the insulation, and then I cut off usually the buffer coating on the actual fiber itself so I get the fiber stub that I have to work with. Typically, I'm going to lay it into a cleaver here, and the cleaver, all that is kind of like a little, imagine like a little X-Acto blade in there. It comes down and nicks the glass stub, and then I carefully bend it. This part here is bendable. I carefully bend that, and it breaks the glass fiber. If you've ever worked with glass, if you break it, if you look at the edge of it, is actually very clean clean break, if you will. So when you're doing fiber termination like that, you're actually just carefully breaking the end of the fiber off for a nice clean connection. Next, I would lay my fiber into my crimping frame here. This lifts out of the way. My connector goes in here. I carefully feed the fiber stub in, get it all aligned, and I carefully pull this handle down on top to kind of crimp it in place. That's kind of your field termination crimping of your outlet, if you will. And then as it goes into the connector, I worry about literally having this fiber connector coming in and this fiber connector coming in and the adapter in the middle aligning them. That is a worry when dealing with fiber optic. The connector itself must align those fiber optic cores up so that I have maximum transfer, and that's what's showing you here. The connector itself has to worry about lining these two fibers up so we don't have leakage of the signal because things aren't lined up or things aren't basically aren't lined up, that I'm getting maximum transfer of light from one fiber to the other one. Think about taking two garden hoses and holding them together with your hand. If I hold them well, I get a little bit of water leaking out, but I get most of the water going from one hose to the next. But if I get them out of alignment, I got a lot of water spraying everywhere. That's the kind of thing you're thinking about when lining these two fibers up. And the connector itself has to worry about getting these two fiber cores lined up that I have maximum transfer of light from one fiber to the next. If not, I have what's called insertion loss, insertion loss from one fiber connector to the other fiber connector. Typically, I'm dealing with two fibers, like we talked about before. One strand is transmit, one is receive. So anytime I'm dealing with fiber connections, I have two fibers I'm dealing with, one send, one receive. The outlets themselves are really just two fibers into a plate, two fiber optic connectors into a plate with two fiber optic connectors into the plate. That's all we're really dealing with. That's why this chapter, it first seems like we're dealing with like fiber patch cables. Well, it kind of is. The outlet jack here is just a connector so that my two fiber cables coming into the back line up with the two fiber cables coming into the front. So the adapter itself is really just holding these fiber optic connectors in place. The plate is mounted in the box. The user fiber is connected to the front. The actually installed fiber connectors go to the back, and typically what happens is the crossover is taken care of at the back of the plate. So the user just worries about plugging it here. We take care of the crossover on the back for them, because if I'm going to connect a transmit on my end, it needs to go to a receive on the switch, if you will. So we need to make sure a crossover occurs behind the adapter plate here. That way a transmit from the user computer will eventually make it into the receive cable over here to the switch, if you will, going back to the data closet. So any crossovers we would need, we take care of behind the plate here. That's what the book was talking about. So when I deal with fiber optic, what kind of connectors do I run into? The book mentions a couple. I'm going to mention one or two more for you. The main ones you would encounter over time are ST, SC, and then the small form factor connectors of MTRJ and LC. So let's go through those. The book start off mentioning the SMA connector. This was a screw type termination. It's not frequent at all today, but this was a connector often used in early fiber connections, a kind of a screw-on termination. The ones you would probably see over time were ST, SC, MTRJ, LC. Well, some of your older fiber equipment had ST, SC in. Stuff that's, I don't know, maybe a generational, you might see MTRJ. Most modern equipment comes with LC, just kind of giving you a quick rundown timeline-wise. So as I look at these ST, we actually do have a couple ST media converters we'll deal with later this semester. The ST connector kind of reminds you of like a little mini BNC. It slides into the connector and does a little quarter twist lock to lock it in place. Here's kind of the end here. Here's the end here. This is actually a real good picture here. As it slides on, this little twist lock goes about a quarter turn, half turn kind of thing to lock in place, to lock it onto the connector. Slowly replace the SMA. Still a single connection. I still need to worry about transmit and receive. So along the line, eventually this started getting replaced by the SC. Good fiber alignment, good connection. It was actually recommended by the 568A standard, and that was the one that was recommended for a while. Later standards said, okay, that's allowed, plus it allowed some other ones down the road too. This style I have, it's kind of reminds you of like a little plug that you just slide in, a little square plug that you slide into the port. Here's a better close-up here, and it is keyed, so you can only get it in one way, if you will. But I still did need two fibers, one send, one receive here. That was your SC. And then along came the standard, said, well, you're allowed to use SC, but you're also allowed to use any other fiber that meets blah standard. So in other words, if it was good enough to meet XYZ standard, it could be used. So a whole bunch of small form factor connectors came along that allowed for both fiber, both transmit and receive, to be in one connector. So things like the OptiJack came along, things like MTRJ, things like LC came along because I could put both fibers in one connector. So the first one that kind of you saw adopted with a lot of gear, and actually some of our switches in the lab have MTRJ ports in, is the MTRJ connector. And as I look at the end here, I have two little dots. Those are the two fibers. So that one little mini connection, it kind of reminds you of a mini RJ45, had the two fibers in. So one plug in into my switch, and I'm good to go. Then that started getting replaced by LC, and it kind of reminds you of the same thing. It's like two individual connectors with a little frame around to hold them together so you have a send and receive. Most modern fiber equipment that you would deal with LANs right now have LC connections in. This would be the common one. We will be using some LC cables later this semester as well to connect our switches together in the lab for a backbone lab. And again, I'm just reminding you here, the outlet box itself has just basically an adapter in that the patch cables are plugging in the back, patch cables plugging in the front. That's all really your outlet box is. So it starts looking like this. Here's an SC faceplate, here's an ST faceplate, there's an LC faceplate, and really the faceplate's just holding that connector so that my patch cable can plug in the front, and I have the same thing plugged in on the back, if you will. That's all that's really going on. Most modern equipment today is using LC fiber ports, and here's an LC fiber port that is actually a there's the one LC port, there's the other LC port, transmit receive, if you will, so very small. The book talks about what fiber connector to use. Well, really, you can use adapters and converters to get what you need, but most modern equipment right now is using small form pluggable modules that use LC connector port, so that's kind of the thing you're going to run into. But I'm also going to remind you, with media converters out here, I can also adapt to what I need. So if I only have a copper port in my router, if you will, I can use a media converter and get to a fiber port that I need. Or in my switch, I have a SFP slot. I can buy the module I want, the SFP module, slide it in, and I keep looking, I'll find what I need. Well, most of these are LC, so most of my fiber ports will be LC for connecting, switch to switch kind of thing in my network. The last part of the chapter, they start talking about marking outlets, and they refer to the ANSI TIA 606 standard. One of the few times we'll mention it, but I will point it out. In your standards reference guide, after the 568 standard and the 569 standard, the next one on the list is the 606. And the reason it is because this is one about documenting and labeling all of your infrastructure. If I scroll down in here, just a handful of pages, I think it's right here, there actually is a whole page of guidelines on labeling your infrastructure. And what I did was I just kind of copied them over to here for us to look at. Let me just highlight a couple of these. The standard says I should be labeling all my spaces with room identifiers. My cabinets and racks should be labeled with identifiers. I should have text on labels shall be I'm trying to read too quick, I'm sorry. Any labels should be machine printed, that way they're legible. Patch panels should be labeled with identifier. Unique campus or site identifier shall be assigned to each campus or site. Unique building identifier. All ports and patch panels shall be labeled. And it goes on and on. But a lot of these, when you really start thinking about it, are some really good common sense things. Cables terminating patch panels shall be identified. Each interbuilding cable should be assigned a unique identifier. Equipment outlets and their associated ports shall be labeled. This is the one we're really getting at for this chapter. And so forth, so forth. And last one down here, detailed records shall be maintained as defined in the standard. Yes, absolutely. We need to label and document what we're doing, and we'll be doing that on our project this semester too. So here is something I found. Let's talk real quickly, because we're talking outlets and work area outlets. Let's talk about a good faceplate idea that I would have, or a good faceplate ID or identification that I would use. And let me start with this real quick here. This is actually a cable label I saw on a faceplate one time. This was actually the label that was on the faceplate. You know, B01, R201, P102, WA, PA24. This is kind of extreme, but here's the crazy part. I found out what the key was. B01 was building 1 in the company. R201 was room 201. P1 was faceplate 1 in the room. 2 was the jack in the faceplate. WA was the 568A color code. PA was patch panel 1. 24 was the port on that patch panel. That was kind of extreme, but every piece of information you need is there. But I think you could boil that down a heck of a lot easier, because there's some of these things that could be cut out, especially the color code. If your whole building should be 568A, so drop that out of there. And what really matters is what you're using in your building should make some sense. So here's something that might work in, our Midtown 2 building, the lab we're using. I might label my outlet jack with something like 2020324. And if I start looking at it, 2 can identify the building and the company, or our campus, if you will. Maybe a number all the buildings and all the campuses, and that's your first number. So that would identify Midtown 2 as opposed to Midtown 1, if you will. 203 identifies the wiring closet room number, or what room number I'm dealing with. Okay, and then 24 would be the patch panel port number that I'm dealing with. And again, if this gets larger, I could add in here an A or a B to indicate, patch panel A as opposed to B, or room closet, closet A as opposed to B kind of thing. But I want to find some kind of scheme that's nice and tidy, but I can look at and know, where is this cable going? What room is it going to? What closet is it going to? I want to be able to look at this and identify where it's going. I don't need to go quite as extreme as we saw in this previous example. Probably more towards this end, but I need a scheme to identify what room is, what building is this in, what closet is this in, what room is this in, what patch panel port kind of thing. Again, we're going to need to do this in our plan too. Keep it simple, document. Keep it simple, document. Last thing they mention is workmanship. When we're dealing with terminating, well, as we start doing our work area outlet termination, we'll work on this, watching the amount of untwist and terminating, and you leave a little bit of cable extra in the outlet box for terminations and fixing, but I don't leave a lot. So we'll talk about some of these workmanship things as we terminate our outlets in the lab. And that's really the end of Chapter 6.